Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which merges two binary tree by doing node sum. First, let us take an example. The merge rule is that if two nodes overlap, then sum node values up as the new value of the merged node. Otherwise, the non-null node will be used as the node of the new tree. Now, let us have a look at the algorithm which will assist us in merging two binary trees. Let us also have sample trees to test our algorithm. We pass the root nodes of both trees to function merge trees. So, T1 will point to 2 and T2 will point to 3. We check if either of them is null. Since it is not, we make T1 equal to T1 plus T2. So T1 will now be equal to 5. Next, we call for the left subtree of T1. Hence, we pass T1's left and T2's left to merge trees using a call stack. Again, we replace T1 with T1's data plus T2's data. So, T1 will be replaced by 7. Next, we pass the left child of 7 in tree 1 and left child of 6 in tree 2. Since left child of 7 is 5, so T1 will point to 5 and T2 will point to null as 6 does not have a left child. Since T2 is null, we return T1. Hence, 5 remains 5 in tree 1. We continue execution for node 7 and now pass the right child of T1 and T2. So, T1 will point to null as 7 does not have a right child and T2 will point to 6, 2 as 6 right child is 2. Since T1 is null, we return T2 which is 2. Hence, 7's right will be 2. We return T1 which is 7. We continue execution for node 5 and now pass the right child of T1 and T2. So, T1 will point to 4 and T2 will point to 1. We replace T1 with T1's data plus T2's data. So, T1 will be equal to 5. We call for the left child of 5. Hence, we pass the left child of T1 and T2 which are both null. Since both are null, we return to the call stack. Now, we call the right child of 5. So, we pass the right child of T1 and T2. Since T1 is null, we return T2. Hence, 5's right will be 7. Finally, we return T1. Hence, we return 5. We finish execution of this program and return the root node of tree 1 which is 5. We have the final merged tree in tree 1. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.